Welcome back, learners! Please click subscribe to learn more from our future videos. Thank you! In this video, we're going to apply the different multiplication methods such as the lattice method and the line method. For our first example, let us have 34 times 7. 34 and 7 are called factors, but they also have specific names. 34 is called the multiplicand, while 7 is called the multiplier. Before we apply the lattice method and the line method, let us first get the answer to this by using the normal multiplication method, which we call the vertical multiplication. To do this, we align the digits according to their place values. In this case, the 4 and the 7 are both the ones digits. Then we multiply the ones digit of the multiplier by each of the digits in our multiplicand, starting with its ones digit. So we have 7 times 4, which is 28, but we will not write 28 this way. This 2, which is the tens digit of the product of 7 and 4, should be written on top of our tens digit of the multiplier. Then we multiply the ones digit of our multiplier to the tens digit of our multiplicand. The product of 7 and 3 is 21 supposed to be, but we have a 2 here which we add to 21. So the answer should be, instead of 21, 23. And since there are no more digits in our multiplier, then 238 is our final answer here. Now let's have the lattice method of multiplication for our 34 times 7. Number of digits in our multiplicand will tell us how many columns our table will have. In this case, since our multiplicand is 34 and there are 2 digits, then we should have 2 columns in our table. And our multiplier 7 will tell us how many rows our table will have. Since 7 is just a 1-digit multiplier, we only have 1 row for our table. Now let us place our factors. The 34, the multiplicand, will be on the columns, and then 7 will be on the row. And then let us draw diagonal lines, or we cut each cell in our table with a diagonal line like this. This is where we will place the digits of the product of our numbers. So we have 4 times 7, which is 28. So we write 28 like this. And then 3 times 7, which is 21. So we write 21 like this. And then what's next for us to do is to get the sum of each diagonal group. So for this one, we only have an 8. And then here we have 2 and 1, which sum to 3. And then for this group, we only have 2. And then we just write the numbers accordingly. 2, 3, 8. And that's it. That is our final answer for 34 times 7. Now let's try the line method. Each digit in our factors will tell us how many lines we will draw. Here, since our multiplicand is 34, so we draw the lines, 3 lines for 3, 1, 2, 3, and then 4 lines for 4. 1, 2, 3, 4. For our multiplier 7, we will draw 7 lines intersecting our earlier lines. We have 1, 2, 3, 4, 5, 6, 7. Then you will see here that there are 2 groups of intersection points. We will will be counting these intersection points. Like we have, for the first group, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we write 28, but again, the 2 should be carried over to the next. The other group will actually tell us the 10th digit of our product. So we only have 8 from this group, and then let us count the intersection points from the second group. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 intersection points, and if we add the 2 from the first group, then we have 23. So we have 23 from this group, 8 from the first group. So we have the final answer, 238. Now for our next example, we have 14 times 21. Let's have the lattice method first. Here we have 2 columns, one for each of the digits of our multiplicand 14, and 2 rows also, one for each of the digits of our multiplier 21. Now let's divide each cell using a diagonal line like this. Let's extend so we can really see the group of numbers later. Okay, there. Now let's proceed to multiplying the digits. We have 4 times 2, which is 8. So we have 0, 8. And then we have 4 times 1, which is 4. So we have 0, 4. Then we have 1 times 2, which is a 2. So we have 0, 2. And then 1 times 1, which is 1. So we have 0, 1. Now let's proceed to adding the numbers in each group. So for this group, we only have a 4. Okay, here we have 8 plus 0 plus 1, which is a 9. Then we have 2 and 2 zeros, which sum to 2. And then we have a 0, which is just a 0. So if we write our numbers accordingly, we have 0294 or just 294. And that's it. That's the product of 14 and 21 using the lattice method. Now let's have the line method. So our multiplicand 14 has the digits 1, 4. That will tell us how many lines we will draw. So we have to start from the top. We have 1 and then the 4. 1, 2, 3, 4. And then our multiplier 21, we have the digits 2 and 1. This time we start from the bottom. We have 1, 2, and then the 1 in 21. 1. So in this case, we see that we have formed 3 groups of intersection points. So we have the first group. Oops, let me draw a better circle there. We have 1. Then here's the second group. And then here's the third group. Okay, now let's count how many intersection points are in each group. So here we have 1, 2, 3, 4. So we have a single digit 4. Here we have, let's use a different color. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the digit 9. And lastly, from our third group, we have 1, 2. So that's a 2. And then we write the numbers accordingly. So we have 294 as our product using the line method. And of course, it is the same as the one we got from using the lattice method. Now let's have 24 times 13. So again, this is a 2 by 2 table. We have 2 digits in the multiplicand and 2 digits in the multiplier. So we draw a table that has 2 columns and 2 rows. Now let's place our digits. We have 24 and 13 on our rows. And then again, let's draw the diagonal lines that divide each of the cells. There. And now let's proceed to multiplying our numbers. So here we have 4 times 1, which is a 4. So for this cell, we have 0, 4. Then 4 times 3 is 12. So we have 1, 2. Then we have 2 times 1 is a 2. So we have 0, 2. And 2 times 3, which is a 6. So we have 0, 6. Then we add the numbers in each of the groups. So here we have, let's use a different color, the purple one. So in this group, we only have a 2. So we have 2. There's only 2 here. Then we have 4 plus 1 plus 6, which is 11. So we write the 1's digit here and the 10's digit of 11 there. Then we have 0 plus 2 plus 0 plus 1 is a 3. Then we have a 0 here. Then we write the numbers accordingly. 0, 3, 1, 2, which is just a 312. And that's it, our product for 24 and 30. For the line method, we have the multiplicand 24. So we have 2 and 4 starting from the top. So we have 1, 2. And then the 4, 1, 2, 3, 4. And then the multiplier 13, 1, 3 starting from the bottom. We have 1 and then the 3. We have 1, 2, 3. And then let us distinguish the groupings here. We have first group, we have the second group, and the third group. And count the intersection points in each group. So for the first group, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But we only write the 10th digit of 12 and the 1's digit of 12, which is 2, and the 10th digit will be included in the next group. The 1 is here. So here, how many intersection points? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus the 1 earlier. So there are 11. So we write here the 1's digit of 11 and the 10th digit will be here in the next group. So how many do we have here? We have 1, 2 plus the 1 earlier, a total of 3. So we write the numbers accordingly. We have the product of 312. Next we have 34 times 12. So for the lattice method, we have 2 digits of the multiplicand, that means 2 columns, and then 12 as our multiplier, which has 2 digits. That means we have 2 rows in our table. We have a 2 by 2 table. Now let us place our digits. We have 34, that's 3, 4, and 12. So that's 1, 2. And again, let's not forget to draw diagonal lines on each of the cells in our table. Yeah. So let's now proceed to finding the product. So we have 4 times 1, which is a 4, so that's 0, 4. Next, we have 4 times 2, which is an 8, so that's 0, 8. We have 3 times 1, which is a 3, so that's 0, 3. Then 3 times 2, which is a 6, so we have 0, 6. Now let's proceed to adding the numbers in each group. So for this group, we have just an 8. So we have 8. Then we have 4 plus 0 plus 6 is a 10. So we have 10, but instead, this one will be written here on the next group. So only the 0 in 10 will be written, or we will get from the second group. And then we have here 0 plus 3 plus the 1 earlier. We have a 4. Then here it's just a 0. So we have 0, 4, 0, 8, or just 408 as our product. Let's have the line method. So we have the multiplicand 34, 3, 4. Starting from the top, we have 3 sticks or 3 lines. 1, 2, 3, and then 4. We have 1, 2, 3, 4. There. So we have 3, 4. And then we have 12 as our multiplier. So we have 1 line and 2 lines starting from the bottom. So we have 1, and then the 2 here. We have 1, 2. There. So we have the multiplier 12 there. And then let us distinguish the groupings. So we have this first group, this is the second group, and the third group. And let us count how many intersection points are in each group. So from the first group, we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. Next, from the second group, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But again, if our answer is a 2-digit one, we just take the ones digit. So 10 is written like this. We only take the 0 and the 1 will be included in the next group. Then we have 1, 2, 3 and the 1 earlier. So it's going to be 4. So if we write our answer accordingly, we get 408 also as our answer. So you choose which one for you is easier. Is it the normal, the traditional one that I presented earlier in this video, or which one between the lattice or line do you prefer? It's okay to, it's always better to have options, right? Now let's have 78 times 14. For the lattice method, we'll be needing 2 by 2 table. So we have 1, 2 columns and then 2 rows. And there's 1 row and then the second row here. Then let us place our digits. We have 78 in the columns, the multiplicand, and then the 14, the multiplier in the rows. And then again, let's draw diagonal lines on the cells. This is where we will place the digits of the products. Then we have 8 times 1, which is 8, so that's 0, 8. We have 8 times 4, which is 32, so that's 3, 2. Then 7 times 1, which is 7, so that's 0, 7. And lastly, 7 times 4, which is 28, so we have 2, 8. Now let us get the sum of the numbers in each group. So here in this group, we only have a 2, so it's 2. And then for this group, we only have, we have 8 and 3 and 8, which total to 19. So we only take the ones digit of 19 and the tens digit will be in the next group. So we have 0, 7, 2, and 1, which total to 10. Right? So again, we only take the ones digit of 10 and the tens digit of 10 will be in the other group. So here we have 0 and 1, which is 1. So we have 1092, 1092 as our product of 78 and 14. Now for the line method, we have 78 as our multiplicand. Whoa, these are a lot of lines. So we have 7 lines and 8 lines starting from the top. Let's have the 7 lines first. How do we draw them? We have 1, 2, 3, 4, 5, 6, 7. And then we have 8 lines. So we have 1, 2, 3, 4, 5, 6, 7, 8. Then we have 14 as our multiplier. So that's 1 and 4 starting from the bottom. So we have 1 and then the 4. So we have 1, 2, and extend the lines so we see intersections. So where are we? We need 4 lines for the 14, for the digit 4 in the multiplier 14. So 3, extend more, and then 4 there. So it's important that we distinguish the groupings of the intersection points. So we have the first group where the ones digit of the product will come from. Oops. Let us include every intersection point in our grouping. So there's the first group. Here's the second group. And the third group. Okay, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The 2 8s. Actually, there are 4 8s here. So 4 eighths is 32, right? So we only write the ones digit of 32, which is 2, and the 3 will be included in the next group. The 3 here, there. So 1, 2, 3, 4, 5, 6, 7. How many sevens? There. So 4 sevens, which is 28 from this upper part of the second group. So there's 28, 29, 30, 31, 32, 33, 34, 36 plus 3, this one. So that will be 39. So we only write the ones digit of 39, which is 9, and the 3 will be included here. So here, how many intersection points? 2, 3, 4, 5, 6, 7 plus the 3 earlier. So there's 10. So if we write the numbers accordingly, we have 1092. So 1092 or 1092 as our product using the line method. Now let's have 421 times 12. So there are 3 digits in our multiplicand and 2 digits in our multiplier. So for the lattice method, we'll be needing 3 by 2 table. So we have 3 columns. 1, 2, 3. And then 2 rows. 1, 2. And then we write our digits here, 4, 2, 1. And then the multiplier digits 1, 2 on the rows. So let's divide. Let's draw diagonal lines on our cells. There. And then let's get the products of these digits. So we have 1 times 1, which is a 1, so that's 0, 1. 1 times 2, which is a 2, that's 0, 2. 2 times 1, which is a 2, so that's 0, 2. 4 times 1, which is a 4, so that's 0, 4. And lastly, not yet. What did I skip this? 2 times 2, which is a 4, so that's 0, 4. And lastly, 4 times 2, which is an 8, so that's 0, 8. Then let's get the sums from the groups. So here we only have a 2, 1 plus 0 plus 4 is a 5, 0 plus 2 plus 0 plus 8 is a 10, so 2 digit, right? So we only get the ones digit and the tens digit will be included in the next group. So we have 0 plus 4 plus 0 plus the 1. So we have a 5 and then just a 0 here. So the 05052, which is 5052 as the product. So see the benefit of this lattice method. I think it's the process is shorter than when you do the traditional multiplication. Now let's have the line method. We have 4, 2, 1, 3 digits in the multiplicand. So multiplicand, so we start from the top. We have 4 lines, 4, 1, 2, 3, 4, and then 2. So we have 1, 2, and then 1 for our multiplicand. 4, 2, 1. And then for the multiplier 1, 2, we start from the bottom. So we have sorry, we have 1 and then the 2 here. 1, 2. Okay, so let's distinguish the groupings that we have here. So we have the first group, the second group here, then the third group. We have 4 groups here. There. So from the first group, we have 2 intersection points. From the second group, we have 4, 5. We have 5 intersection points. From the third group, we have 8, 9, 10. But we take only the ones digit of 10 and the tenth digit 1 will be here. 1, 2, 3, 4 plus the 1 earlier, so 5. And write the numbers accordingly. We have 5052. Same answer that we got. Same compared to the earlier answer. Now we're down to our last example in this video. 326 times 72. So for the lattice method, we have 3 digits in the multiplicand, 2 digits in the multiplier. So we'll be needing a 3 by 2 table. So 3 columns and 2 rows. So we have 1, 2, 3 columns. And then 2 rows. So that's 1, 2. There. So the multiplicand are in the columns 3, 2, 6. And the digits of the multiplier are in the row. So 7, 2. And again, let's draw the diagonal lines that divide the cells. There. And let's get now the products of the digits. 6 times 7 is 42, so we write 4, 2. Then 6 times 2 is 12, so we write 1, 2 for 12. Then we have 2 times 7, which is 14, so we write 1, 4 for 14. 2 times 2 is 4, so we write 0, 4. 3 times 7 is 21, so we write 2, 1. And 3 times 2 is 6, so that's 0, 6. And then let's get the sums of the numbers in the groups. So in this group, we only have a 2, so this is 2. And 2 plus 1 plus 4 is 7. 4 plus 4 plus 0 plus 6 is 14. So it's a 2-digit product. We only take the 1's digit and the 10's digit will be in the next group. So there's your 14. And then 1 plus 1 plus 1. This is just a 0. So a total of 3 and then a 2 only here. So we have 2, 3, 4, 7, 2. So 23,472 is our product. Very fast. And then for the line method, I hope the space is okay. Let us just make our writing a little thinner. So we have 3, 2, 6 starting from the top. Since these are numbers or digits from the multiplicand, we have 3, 1, 2, 3, and then 2. So that's 1, 2, and then 6. 1, 2, 3, 4, 5, 6. Then we have 72 from the multiplier. 7 first. So we start from below. So we have 7. Wait, let us just extend these lines. We have 7. 1, 2, oops, sorry. 3, 4, my lines are getting wavy. 5, 6. Oh no, that's only 6. We need 7. So let's put the other line here. 7 there. Then the 2, 72. So we have a little away from the 7. So 1, 2. So for you to use the line method, you should be very good at drawing lines, as in lines drawn from one another. So we have the first group. Oops, this is supposed to be the first group. This is the second group. Then the third group. Oops, wait. So we have the third group here, and then the fourth group here. So let's count how many intersection points do we have from each group. So from the first one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 1's digit of 12 is 2, and the 10's digit 1 will be included in the next group. So how many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, and the one earlier. So that's 47. So we only take the 1's digit of 47, which is 7, and the 10's digit 4 will be included in the next group. So let's count the intersection points. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Plus the 4 earlier. So that's 24. So we only take the 1's digit 4 and the 10's digit 2 will be included in the next group. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 plus 2 earlier. So that's 23. Then we write all the digits 2, 3, 4, 7, 2. So that's 23,472 also. That's it. So if you want more examples, you just comment the numbers that you would like us to try. Or if you have tried it and you want to see how I will do it in our video in this channel, then please do comment here below our video. Thank you. So learners, what would you like to learn next? Comment below.